In this lesson, we're going to look at onboard earth faults. Let's start by looking inside one of our AC appliances. This is an example of a typical onboard 230 volt AC electrical appliance. It could be a microwave, for example, but this applies to all appliances that have any exposed metal parts. We have the standard 3 conductors wired as shown. There's a live, neutral, and safety earth. The earth is connected to the casing of the appliance, and often this is also connected to any other internal components that require earthing. So if we were to have an internal fault on our appliance, such as an internal cable coming loose, as often happens on boats with all the movement and vibration, we now have a fault current to the case of the appliance. Let's look at the fault current path within the appliance. The fault current has made it to the earth terminal of the appliance case. Now let's look at the fault path from the appliance all the way to the shore supply. The fault current, shown by the red dot, makes it all the way back safely to the shore pillar earth connection. The RCCB on board will disconnect the supply instantly if the earth fault current is any higher than 30 milliamps. Even if there was no RCCB on board, in European marinas there's often an RCCB on the shoreside feeder pillar. This is time delayed, so it gives the onboard RCCB first opportunity to disconnect the supply. If there is no RCCB on board and none on the shoreside pillar, then this fault current will just continue to flow indefinitely, or until there is a fire in the appliance. Many accidents and deaths are caused, however, by a combination of faults. In this diagram, we have a very dangerous combination of faults. We still have the appliance on board with its fault to earth, but we now have an additional fault in the form of a break in the protective earth conductor of the shore power lead. This combination of faults renders the case of the appliance partially live, and it runs the earth fault leakage current through the water back to the shore pillar. Let's follow the current indicated by the red dot. If anyone happens to be in the water during this fault, they are in a very dangerous situation. Many people are killed each year as a result of what's called electric shock drowning. This is where a very small fault current can render a swimmer paralysed, so they can't swim back to the surface. Electric shock drowning has 2 main mechanisms: electrocution and drowning through paralysis, or in some cases it's a combination of both. In salt water though, it's more likely to be electrocution, as salt water has such a low resistance. The voltages are much higher and carried further distances. As the resistance of salt water per metre is so much lower than that of a human body, the fault current would much rather take the easier route and flow around a swimmer rather than through. So in salt water, the swimmer is at more risk of electrocution and less risk of paralysis. If we consider the same fault situation in a freshwater environment, there is now much more likely to be drowning from paralysis risk. This is because freshwater has a much higher resistance, anything from 2 to 100,000 ohms per metre. And this is much higher than the resistance of a human at around 150 ohms per metre. So in fresh water, the electrical current will find it much easier to pass through the lower resistance swimmer than it would to pass through the much higher resistance water. So the swimmer becomes a focal point for any stray currents. We can control these risks with a simple but very strict onboard safety policy. But ultimately, it's better to simply not swim near vessels with their shore power connected. As we've covered earlier, whenever disconnecting the shore lead, disconnect the shore power from the dock side first and then the vessel, never the other way around. When reconnecting, connect the vessel first and then the dock. Do not connect shore power if there are people in the water. Always supervise children, and if you see anyone in difficulty in the water near your vessel, disconnect the shore power before helping them. Regularly test your shore lead earth conductor for continuity. You can do this with a standard multimeter. Avoid swimming in marinas or any other areas near other vessels with shore power connected. The vessels nearby may have faults that can kill you. If you do need to swim in the marina for repairs to your vessel or to clear a fouled propeller, for example, then always disconnect your shore power and stow the cable away. If you have a diver down working on your vessel, place a warning sign over the shore power inlet. Make sure your vessel has a functioning RCCB covering the whole boat's AC installation, not just the socket outlets. It's vitally important that you test these at least monthly by pressing the test button and then resetting the device. How to do this is covered in the RCCB section of this course. And lastly, but by far the most important point of all, have your onboard electrical system regularly professionally tested. You can also have any portable onboard appliances professionally tested too, with what's called a portable appliance tester. Ask your electrician about PAT testing. In this lesson, we have covered AC earth faults.